Okay, let's get started. Good morning, everybody. Very warm welcome to this second session of the NOMAD Summer School, which is about advanced graphics. In the beginning, I'd like to give you just a very brief overview of the activities we are doing in NOMAD concerning graphics and visualization, and give you some guide through the program of this morning's session. Now, you might wonder about the title Advanced Graphics. I mean, graphics is everywhere and everybody is doing advanced things. So what are we doing specifically in NOMAD? What we think hopefully deserves the name Advanced Graphics. So this is mostly three things which I'd like to mention here. The first thing is, so we try to develop and apply advanced methodologies, which means we want to go beyond the tools of the trade or the methodologies which are conventional and used in this field. Namely, we want to go beyond the visualization of molecular trajectories, let's say, and for example, also give you access to larger and more complex types of data which are present in the NOMAD repository, or in the NOMAD archive, I should say. Second, we would like to enable the exploration of higher dimensional spaces, also abstract spaces, using virtual reality. And my colleague Ruben has an entire slot about this, so I'm not going to steal any show from him. What he's going to demonstrate is that this is going way beyond the conventional visualization techniques which are used on two-dimensional screens, say. Second, in order to accomplish this, we need to adopt new technologies, and that is mostly two things. Virtual reality. There are devices around. Here are a couple of them in the box, and Ruben is setting up some of them. Namely virtual reality glasses or goggles in some sense, and I've listed a few of them. And second, we want to enable just via the browser interactive remote access, and I'm going a little bit into more details on that part in a minute, to the data in the NOMAD archive. And specifically, we are using technologies like novice and containers in order to enable this. And actually, this is a screenshot of a demonstration which just shows a complex visualization in a tablet in this case, right? Third thing which we think is beyond standard is that we are producing advanced material for training, dissemination, and education purposes. That is hosting dedicated events and workshops, and this is another one of this class. Ruben will show all these things, which I've just put a few screenshots here. And second, we have produced high-quality movies for dissemination processes, and you may have seen this one, or some of you may have seen this one, which I'm going to play here. But I think it is fun and a nice one, so I'm going to play it here again. So it has appeared on all channels supported by NOMAD here. So let's just look and listen.
Also called quicklime, which is an important natural process that is also used in industry. The movie is the result of an electronic structure calculation. Calcium atoms in the surface are represented by gray spheres, the oxygen atoms by red spheres. The carbon dioxide, or CO2 molecule, is shown as a white sphere, the carbon atom, between two red spheres, the oxygen atoms. When CO2 is far from the surface, the molecule is linear. The atoms in the CO2 molecules are held together by chemical bonds created by the electrons. When the CO2 molecule gets close to the surface, the electrons redistribute. The movie shows the change of the charge density of the electrons. The red color reflects an increased electronic charge density, while the blue color marks a depletion of electrons. The new shape of the electronic charge density indicates that the formerly very stable CO2 molecule is now ready to undergo the desired chemical reaction. The process is shown in slow motion. In reality, it happens 20 billion times faster. Why is this interesting? Carbon dioxide is a highly problematic greenhouse gas that is produced, for example, by cars, as well as in the steel and cement industries. CO2 emissions are the main reason behind man-made climate change. However, in principle, it is also possible to use CO2 as a beneficial raw material for making valuable chemicals, including fuels for transport and for heating. Movies like this allow us to observe processes that are a quadrillion times faster than a blink of the eye, and to see atoms and molecules that are tens of millions times smaller than a grain of sand. This helps us to look deeper than ever before into the processes at the surface of catalysts that are used extensively in industry to accelerate chemical reactions. The NOMAD teams in Barcelona and Berlin are working towards a deeper understanding of catalysis, which will enable, amongst other things, new, more efficient catalysts for CO2 conversion to be developed.
Okay, now this movie has been produced using the tools and technologies which we are developing and which will also be available to NOMAD users. So in principle, there's lots of fine-tuning in producing such a movie as you can imagine, but in principle, NOMAD users are able to produce such a movie or such visualizations on their own. And the tutorial in the computer rooms later today will take specifically this example and guide you a little bit through the workflows and the necessary steps to generate such visualizations, or also do quantitative analysis on this data. And the underlying technology here is what we call, or what is called commonly, it's not new, remote visualization. So we enable interactive access to the complete data sets, so to say. And if you look into the contents of the NOMAD archive, just a very, very rough classification here, you have what we call in this context small data sets, which might be geometries, trajectories, and so on, which you can easily visualize using whatever balls and sticks and something. So this is not limiting here. But if you want to go to the second class here, like scalar fields or even vector fields, if you have electromagnetic fields or something, you're generally dealing with quite large data volumes, at least in the gigabyte range, for ab initio molecular dynamics, for example. And we noticed that the tools which are available in the chemistry or physical chemistry community are concerning visualization are not that complete in this respect. And the technical solution to enable this is we are running the visualization software within the NOMAD data center, which means that the analysis and the software runs very close to the data and can make use of specialized hardware, for example, GPUs, and also maybe complex software installations. So there are no special requirements for your device concerning hardware and software, so you don't have to install anything on a tablet or PC or laptop or whatever. And basically the user just interacts with a remote desktop. And this is, in general, an established technology which is used heavily in high-performance computing, in scientific high-performance computing, and other fields. What we are doing here is we are enabling this browser access, and all you need is a reasonably modern browser for this. And this has not been so common in the field so far. Now this tries to summarize a little bit what I've said a minute ago. So you have the NOMAD archive, the parsed data, let's say, in the terminology, which has been mentioned yesterday. And there is machinery or machines which host this remote visualization service. And what happens is, in a user-transparent way, you do not transmit the raw data here to the client, to your PC or to your laptop, which would be prohibitive for this type of data, but just transform, let's say, a compressed stream of images, which you don't see, of course, as such when interacting with this. There's also other types of reductions which are necessary. So there are these standard visualizations like 2D plots and balls and sticks and whatsoever. Also here the data, the amount of data is reasonably small that you can just transmit the data to a browser. And there's virtual reality where also some reduction is done here at the server side. And then exposed to the clients. You need special hardware in this case, obviously, and we have some demonstrators here. So that leads me to the program. What we are going to teach or to present during this morning. So you will learn about virtual reality, explore NOMAD data in virtual reality, and that is Ruben's part, which will start in a few minutes. You will use this remote visualization, so we're using a demonstrator here, but that will be fully integrated with NOMAD within the next couple of weeks. In order to analyze NOMAD data by interactive remote visualization, the data we are using there is the data which also went into producing the movie I've shown before. In addition, you might be interested in just learning about the tool which we're using here. It's an open source software and completely independent of NOMAD or any activities here. You can download this and install it in your whatever laptop or computing center and use it for general purpose visualization of, let's say, at least three-dimensional data. The big picture will be covered in our keynote lecture by Dieter Granzelmüller. He's director of the Leibniz Supercomputing Center, PI of NOMAD, and also professor of computer science at the Ludwig-Maximilians University. And he will talk about scientific and information visualization, point out possibilities and challenges from the more general point of view. Now, please keep in mind that for organizational reasons, we have to schedule this keynote talk not in this session, but this will take place tomorrow, 10:50 after the coffee break. So we have to switch topics again there a little bit, otherwise Dieter Granzelmüller couldn't have made it there. Now, for the rest of the morning, this is the program. So Ruben Garcia will talk about virtual reality, give an overview first, and then do hands-on demos with the glasses here. After the coffee break, we do tutorials, and we thought it would be probably a good idea to split the audience into two groups. So my colleague Michele Compostela will run the remote visualization tutorial on the first group for something like 45 minutes in the computer room. During this time, the second group can still take the opportunity to explore things here in virtual reality. And after something like 45 minutes, we swap the groups. So hopefully everybody has a chance specifically to use this kind of devices. I think there are a number of them in the box, but probably not 40 or 50 of them. And as I said, keep in mind that the keynote will be tomorrow, not during the day. So just to introduce the team, I've mentioned my colleagues already. So this is Ruben from the Leibniz Supercomputing Center, being responsible for virtual reality developments. Michele here, who is somewhere in the back, will run the remote visualization tutorial. You don't need a picture of mine here. And of course, many people in the NOMAD team have contributed to this. I would like to mention specifically Sergei here from the Fritz Haber Institute, because he's also formally involved in this work package and has contributed a lot to producing also the movie which I've shown. And we're getting good advice from our advisory committees, scientific industry committees, and also the EU reviewers. And with that, I'll take questions and hand over to Ruben for his presentation and tutorials on virtual reality. Thank you very much.